Hi everyone. In this video I'm going to demonstrate Andrew Hay's process macro with a focus on model number 80. So before I get started, I do want to mention that underneath the video description you will find a link to the SPSS data file that I'm working from in this presentation, so you can download the data to follow along. Additionally, you will find a link to a PowerPoint that's going to contain a lot more information than I'm going to be covering in this video. So feel free to download that and study it to learn more. So let's go ahead and begin just by considering the model itself. And so in this model, what we see is we have variable x, which is our independent variable, predicting variable y right here. However, we have several mediators within the model. You'll notice that we have mediator 1 and mediator 2 right here. These are essentially being treated as parallel mediators, and then we also have a third mediator in the model, and this model is following from mediator 1 and mediator 2. So basically mediator 1 and mediator 2 are serially antecedent to mediator 3, and then from mediator 3 we have a direct effect from that variable to y. So in this model, just notice that we have all these different paths that I've laid out, and so paths A through I are considered as direct effects within our model, and what we're going to want to do is not only test the direct effects but also the indirect effects within our model, and the indirect effects carry information about the mediational process. So when you are using Hay's macro, what you're going to find is that it's going to be broken out in terms of our output into several different submodels. So if we go back to our model right here, the first model is going to entail regressing M1, mediator 1, onto our variable x. The second model will entail regressing mediator 2 onto variable x. So that's what's reflected on this slide right here for models 1 and 2. Now model 3 entails regressing the M3 mediator onto x, M1, and M2. So basically if we go back right here, you'll see we have M3 being regressed onto M1, M2, and then our x variable right here. Then the last model is entailing the regression of y onto all of the preceding variables. So we have x, we have M1, M2, and M3. So that's the general layout in the output file that we will be generating. Now in this slide that you see, I'm basically giving sort of a breakdown of the specific indirect effects between our variable x and our variable y. So the specific indirect effects carry information about different mediators of the effect of x on y. So you'll notice that the computation of the specific indirect effects, which I'm denoting as SIE 1 through SIE 5, those are computed as a product of the path coefficient. So you'll see that SIE 1 right here is computed as a product of path A and path B. SIE 2 is computed as a product of paths A, G, and D right here. SIE 3 is computed as a product of path C and path D. SIE 4 is computed as a product of path E and path F. So let's find F. There it is right there. And then SIE 5 is a product of E, H, and then D right up here. So those are all the different ways in which the effect of our variable x, our independent variable on y, may be mediated within this model. And also, if we were to sum up the specific indirect effects between x and y, that would produce another index which is referred to as the total indirect effect. So for our current demonstration, we will be using data from an article by Zhou et al., the relationship between anxiety and burnout among Chinese physicians, a moderated mediation model. So we aren't carrying out moderated mediation in this analysis. And I do want to mention that the scoring of the variables is likely to be different from what the authors actually used. And also the model is definitely not what they were testing in that particular article. So this this presentation is just for a demonstration only with respect to Model 80 using process. So the model that I've laid out essentially has neuroticism serving as a predictor of anxiety. And so the path I that we have right here, this is the direct effect of neuroticism on anxiety, but we're also positing that there are several specific indirect effects through different mediators. So you'll see that we're positing that the effect of neuroticism on anxiety might flow through positive coping, so that would be computed as a product of paths A and B. We would also say that neuroticism has its effect on anxiety through positive coping and burnout. So in that case, that specific indirect effect would be computed as a product of path A, path G, and path D right here. We also have then neuroticism having an effect on anxiety through burnout, so that's another specific effect, indirect effect, computed as a product of paths C and D. We have another specific indirect effect through negative coping, which is computed as a product of paths E and F, and then another specific indirect effect through negative coping and burnout, which is computed as a product of E, H, and D. So here we are in SPSS, and I'm going to go ahead and run the analysis. So I'm going to go to Analyze, go down to Regression, and then go down to Process. Okay, so we have our variables in our data set. So our X variable is neuroticism, so I'm going to move it over to this X variable box. Anxiety is my dependent variable Y right here. I'm also going to move positive coping to the mediator box, negative coping to the mediator box, and burnout to the mediator box. Now, an important thing to keep in mind is that that last variable in this box right here is going to be treated as the M3 variable. So the variables that are preceding that third variable are going to be treated as parallel mediators. And in theory, if you wanted to, if you had multiple parallel mediators, not just two, you could add them in, but that last variable is going to be recognized as your M3 variable, or that last variable that's most proximal to the dependent variable. So just kind of keep that in mind when you're using this. So next we'll go to model number and scroll down to model number 80. And we're going to leave our confidence interval set at 95% right here, and the number of bootstraps samples is going to remain set at 5,000. So the next thing I'll do is go under options right here, and just a couple of things that I've included in the PowerPoint, the main part of the presentation. I just requested effect size, standardized coefficients, and we'll click on continue and then on OK, and so then it begins performing the analysis. And just keep in mind that it does take a few seconds for the computations to carry out, so don't expect it to print out just right away, but it does take a few seconds. So now, looking at our output, you'll see that we have model 80. The description of the model, we have anxiety as Y, neuroticism as X, positive coping, negative coping as M1 and M2, and then burnout as M3. So now going through the sequence of models that I was referring to, the first model is the regression of positive coping onto neuroticism. So the slope right here is negative, and we have statistical significance at the conventional 0.05 level. So neuroticism emerged as a significant negative predictor of positive coping. When we scroll down a little bit further, we can see our second, basically our model 2, where we have the regression of negative coping on to neuroticism, and we have a positive regression slope, and we have statistical significance. So essentially neuroticism was a positive and significant predictor of negative coping. Then when we scroll down to model 3, now in this case we have our M3 variable burnout regressed onto neuroticism, positive coping, and negative coping. So we have our regression slopes and significance tests there. And you'll notice that in this case the the slope for neuroticism, it was negative, but it was also not statistically significant. It was the p-values at 0.5207. We see that positive coping was a negative and significant predictor of burnout, and then we also see that negative coping was a positive and significant predictor of burnout. You also notice that the R-square value for this model is 0.256. So basically the set of predictors were accounting for about 25.6% of the variation, and we also see that the f-test for the model is statistically significant. So now let's scroll down a little bit further and we'll go to model number 4. So in this case, you can see that we have our anxiety variable that was regressed onto all of the preceding variables. So when we look at this, we can see that the direct effect of neuroticism on anxiety, and that's the path I within our original model, or the full path model, we see that that coefficient is positive and we have statistical significance. So neuroticism had a positive and significant direct effect on anxiety. You can see that with respect to positive coping, its effect on anxiety, we can see it's negative and statistically significant. And then we have negative coping, that regression slope is positive, so we have a positive predictive relationship between negative coping and anxiety, and we see that that effect is statistically significant. And then finally we have our burnout, the direct effect of burnout on anxiety. So we see that slope is positive and we have statistical significance. So, and as a set, the variables accounted for about roughly 33.77% of the variation in anxiety, and you can see our F value right there, degrees of freedom, and P values. So as a set, the variables accounted for significant predictive power with respect to anxiety. I also just kind of noticed, I didn't really talk about it, but because we had requested standardized coefficients, we are able to get the beta coefficients for each of these models. So the coefficients that are given for each of them are given in this part of the tables. So we'll scroll down a little bit further, and the first thing to kind of note is that in terms of our output, we get the direct effect of x on y, and that's the path I was referring to. And you'll notice that there it is right there, and you can see that we have our t-test and significance level, and that's actually going to be the same value and test that's given up here in our model 4. So all of that is exactly the same as before. But when we scroll down a little bit further, we have a table containing various indirect effects. And so up here in this table, what we have are unstandardized indirect effects. And you'll also see that we have tables with partially and completely standardized indirect effects. And we're not going to spend any time on those. We're going to be focusing mainly on the unstandardized effects. But I also want to mention too that at the very bottom you're going to find a legend for each of the indirect effects. So you'll see it says indirect effect key, and it's got IND1, IND2, IND3, IND4, and IND5. And you'll notice that for IND1 it's neuroticism to positive coping to anxiety. So that's the first specific indirect effect. The second one, IND2, is neuroticism to negative coping to anxiety. You'll see the third one is neuroticism to burnout to anxiety. The fourth one incorporates our M1 and M3 mediators, so it's neuroticism to positive coping to burnout to anxiety, and then IND5 is neuroticism to negative coping to burnout to anxiety. So that legend is going to be really helpful when it comes to interpreting the results in this part of the table, because you'll see those indirect effects are labeled as IND1 through IND5. So the first part of this table, though, I want to draw your attention to is this total right here. So this is the total indirect effect of neuroticism on anxiety. And so this is computed as the sum of the specific indirect effects that I was referring to down here in this table right here. And really all of these are the specific indirect effects. So if we sum up all those specific indirect effects, we get this total indirect effect in this row. What we have in terms of testing that is a bootstrap confidence interval that's based on those 5,000 bootstrapped samples. That was the default when we went through the original menu system. So the way that you can test the indirect effect right here is to look at the lower and the upper bound of our confidence interval and of 0, which is the null. If 0 falls between the lower and the upper bound, then the indirect effect would not be deemed as statistically significant, whereas if 0 falls outside of the lower and the upper bound, then it would be deemed as statistically significant. So you can see right here that our total indirect effect is 0.1023. The lower bound of the confidence interval is 0.0295. The upper bound is 0.1796. Because 0 does not fall between the lower and the upper bound, we would reject the null that the total indirect effect is 0 and infer that the population total indirect effect is non-zero. When we look at each of our specific indirect effects, again, we would use the same logic with pertaining to testing them. So these are all the specific indirect effects. We have our confidence intervals that are given right here. And you can see that 0 falls outside of the lower and the upper bound of each of those intervals, with the exception of the confidence interval around the specific indirect effect for IND3 right here. You can see 0 falls between negative 0.04 and 0.02. So we would not be rejecting the null in that case. So a couple of other things that I want to draw your attention to is if we go back into our regression right here and go back down to process, under options, another couple of options that you could select is show total effect model and also pairwise contrast of indirect effects. So if I click on continue and then on OK right here, we can rerun the analysis, and we didn't actually have to rerun it. We could have started out by selecting those, but I was kind of I added those to the PowerPoint as an add-on, so that's what I'm kind of covering in the last few slides right here. So looking at our output, I'm going to scroll down, and you'll notice that right here now we have the total effect of x on y. And so the total effect of x on y is computed as the sum of the direct effect of x on y and the total indirect effect of x on y. So we have then a total effect of x on y, and we can also test that for statistical significance. So we have a p-value that's given right here. There's our confidence interval if we wanted to use that for significance testing. But you can see right here that basically the total effect of x on y would be deemed as statistically significant. The actual computed value is 0.333, and again, it's statistically significantly different from 0. The other thing that we had requested were those pairwise contrasts, and so if you scroll down a little bit further, you'll notice that our indirect effect table now has these C1 all the way down to C10 right here. And these are essentially reflecting contrasts of specific indirect effects that we had computed up here. So if we wanted to compare specific indirect effects within our model, we could do that through those tests. And if you scroll all the way down to the bottom, you'll notice that we have specific indirect effects contrast definition. So you'll see that C1 is computed by taking IND1 and subtracting IND2. C2 is computed by taking IND1 and subtracting IND3. So you can see we have pairwise differences that are being computed. So just as an example for the C1, if I go back up here to our first table, C1, you'll notice the contrast estimate is negative 0.0480, and that's just computed by taking the computed coefficient for IND1 and subtracting the coefficient for IND2, which is the 0.0610. So that's what gets us the negative 0.0480, and then you can use the bootstrap confidence interval right here in the same way we've been using it before, which to test the significance for that effect, or in this case we would be testing whether there's a significant difference between those two specific indirect effects. So if 0 falls between the lower and the upper bound, we would not deem that difference as being statistically significant, whereas if 0 falls outside of the lower and the upper bound, then we would deem that that comparison as significant in terms of the difference in those specific indirect effects. And so obviously in this case 0 does fall outside of the lower and the upper bound for that interval, so we would deem that difference to be statistically significant. Okay, so that pretty well wraps up this presentation. Once again, I do encourage you to check underneath the video description and obtain a copy of the PowerPoint. It goes into a lot more detail and probably a lot slower than what I had to kind of go through in this video, but I was trying to keep it reasonably efficient. So at any rate, I hope you guys have a good day, and thanks for watching.